280. 17. Need to find the real zeros of the polynomial using the techniques specified by the instructor. And state the multiplicity of each zero. X cubed. All right. What I would suggest you do is you find all the p's. And the p's are going to be what? All the factors of what?
It's going to be 10.
Factors of 10, right? Or the trailing term back here. So it's plus or minus 1, plus or minus 2. These are integer factors. Plus or minus 5, and plus or minus 10. Any questions on it?
Yeah.
And then the q's are going to be factors of that leading term, right? The 17. Well, the only ones there are is plus or minus 1 or plus or minus 17, right? Now, the p over q. So you have all of, when you put 1 in the denominator, you get all of the ones, that are just the p's in the numerator. But when you put 17 down there, then you get plus or minus 1 17, plus or minus 2 17ths, plus or minus 5 17ths, and then plus or minus 10 17ths. Now, once you get it that far, then what I would suggest you do is graph it. Go take your calculator. And so what we'll do is we'll take and then in your y equals, clear that thing out and graph that. Now it's a minus 17, so you're going to have to use this negative sign right here because it's the first minus x raised to the third power. I got to get that cursor out of the exponent, plus 5x squared, right? Plus 34x. And minus 10. Now we use just the regular minus. Now what do I do? Graph it. And then I look for something that, now it doesn't look like they're on any of those. It looks like it, if it has any possibility, it's going to be on those, the 17 in the denominator, isn't it?
Yeah.
Because it's none of those things are. So you have to take a guess at which one. Now, if what 17 would be this one be closest to? And I'm just arbitrarily picking that. A 2 or a 5? Probably a 5, wouldn't it? 5 17s.
Yeah.
I mean, do you see what I'm saying? That intersection right there. This one down here would be something over 17, negative 17 17ths, and I don't think we got anything there, do we? That's gotta be a 2 or 5. I'm gonna look once again. I'm, I'm thinking that 2 or 5 is gonna be the best one. So we'll try the 5, hope for the best. So I'm going to divide by 5/17. Then I will always put that row up here. It's an x cubed, x squared, x linear, x constant. So then it's a minus 17, 5, 34, and minus 10. Be sure to bring your minuses down. Is everyone? So now what I'm going to do is I'm going to bring that 17 down, minus 17. Then I multiply 5/17 times a minus 17. That's a minus 5, isn't it? It's looking good so far. We got a 0. 0 times 5/17 is 0. 34 comes down. And now 5/17 of 34, 17 goes into 34 twice. 2 times 5 is 10, and I get a 0. That is an intercept, right?
Yeah. So how do we do the multiplicity part again? It's like, what would be like?
Well, is 17 again? Is 17? Is 17? And if it's a intercept again, but notice that we can actually eliminate that idea, because you see, if it was a multiplicity 2, you would have to come down and touch at that point and leave, or else come up from the bottom, because the second degree or fourth degree says that's what it does. It goes through, so it'd have to be, if it were, it would have to go through there, 3 times. It'd have to be, and it isn't going to be 3. Now we got this one right here and this one left. I just want to see the size of that window. I'm gonna do a standard window. 6. I had a window that was a different size. This is a 10 by 10. Okay. So we got these two. But now what we have is we have this reduced polynomial. This thing right here. So what I'm going to write this as, I'm going to write this as a minus 17x squared minus 34 equals 0. See this thing right here is a reduced polynomial, and that's what it is. Do you understand that? Now what I'm going to do, I'm going to solve this thing. So I'm going to get minus 34 here, and I'm going to go over here and do a positive 17x squared. You see I added 17x squared to both sides, right? And now I'm going to get x squared equals a minus 2. And I take the square root of both sides, plus or minus, but that's plus or minus the square root of 2 with an I on it. Did I put that stinking thing in the equation? Did I put that equation in there right? Because this says it has one real root and two complex, and it didn't appear to be that way. Okay, I have a minus 17 plus 5x squared plus 34 minus 10. I got that thing in there right.
You said 2 real zeros? I think there's only one.
Huh?
I thought there's only one.
What are you talking about?
Are you saying, did you say 2 real zeros?
Well, it looks like there's 3 real zeros. And then here's 2 complex. You see when you graph it? You see how many times do you see it across the x-axis?
3.
3 times. I mean, it looks like there's 3 real zeros. And these are given 1 real zero and 2 complex zeros.
Are you gonna give? You're not.
Oh, I see.
This, are you?
I see. Here's a mistake right here. Do you see this right here? This should be a plus. See that?
You said plus what?
And this would be a plus. This would be a plus. So then this is plus or minus the square root of 2. Now it looks better. Right?
Yeah.
Because see it matches this. There's how many real zeros are there? There's one intersection, 2 intersections, 3 intersections. There's 3 real zeros. And see, this would be a plus square root of 2, and that would be a minus square root of 2. That crosses.
So that's where 3 come in.
Yeah.
Okay. All right.
So the zeros are, see, and that's what they wanted. Find the real zeros. So the real zeros are this one, and then these 2. So it's 5/17 plus the square root of 2 and minus the square root of 2. Real zeros. So when I graph it and see when I had a complex zero should not have crossed the x-axis, right?
Mm-hmm.
So I knew something was wrong when I calculated. Does that make sense? That's how when you use your graphing calculator, it'll help you make sure that you get the right answer.
What do you have in?
Okay, do you have any other questions on problems?
No, I thought something.
Should I call you Ryan?
No.
Okay.
Do you want to do problem 9 on page 333?
333?
Mm-hmm.
333. So page 333, 9. It says, use the 6-step procedure to graph the rational function. Now, I just want you to know, you're not going to have to graph a rational function, but I can show you what I will ask. I will ask for the vertical asymptotes, the horizontal asymptotes, the holes, and the slant asymptotes. So we can use this one to figure those out. So f of x is equal to x squared minus x minus 12 all over x squared plus x minus 6. And another thing that I will ask for on this kind of a problem is I'll ask for, you know, what are the solutions? No, I won't ask that. I'll ask for vertical, horizontal, and slant asymptotes. So what you're going to have, your domain, your limit on your domain, and your vertical asymptotes and holes are related. So what you do is you take, and I'll try to do it this way. I'm going to factor the denominator, and that denominator factors into what? X plus 3 and x minus 2. Is that right? Okay. Is that Maria? Okay. Then the numerator, how does it factor? Is it x minus 4 and what? X plus 3. The factoring should be kind of, at this point, pretty much second nature, right? Is that, Maria, is that making sense? You know what we're doing. Now, when you look at it this way, the denominator, where it's equal to 0, where the denominator is equal to 0, x equals minus 3 and x is equal to 2, right? You see where I got that? Now, those two values should be at points where either you have a hole or you have vertical asymptote. Now, one of them is a hole and one of them is a vertical asymptote. And how can I determine which is which? Okay, Savannah says 3 is a hole. Does everyone agree it's a hole? You see why? Because the factor x plus 3 is in the numerator and x plus 3 is in the denominator. That makes it a hole. And the x is equal to 2 is a vertical asymptote. Okay. So what I'll ask, what I would do with a problem like this is I would ask for vertical asymptotes. And this is a good example. Don't say x equal minus 3 and x equal 2 because they are not both vertical asymptotes. Only x equals 2 is a vertical. Then I'll ask for holes. And that will occur at x equal minus 3. Now, the hole is actually, for the graph, it's going to have an arbitrary y value. So you could plug minus 3 into there and try to find it. But I won't ask you that. I'll just say what x value would represent a hole and what x value is going to represent a vertical asymptote. Does that make sense?
So just vertical.
Okay, now, which does this have? A horizontal asymptote or does it have a slant asymptote? Which is it? It's horizontal. Why is it not a slant? What would have to be true about this if it were a slant asymptote? Okay, the numerator has to be greater than the denominator in terms of degrees. More importantly, Aaron, it has to be what greater? 1 greater. And this numerator's degree is what? The same as the degree of the denominator. Now, the horizontal asymptote, so it won't have a slant, it's going to be y is equal to what? Okay, 1. Because what you do is you're going to take, the way you got it, is the numerical coefficient for this x squared is 1, and the numerical coefficient for this is 1, and you put 1 over 1, right? And so then you got y equals 1. If the degree of the numerator were less than the degree of the denominator, the horizontal asymptote would be what? Y equals 0, right? If, I'm just saying, if it were not this way, if the degree of the numerator were less than the denominator, then it would be y equals 0. If they're equal to each other in degree, then it's the numerical coefficients like this. Okay. So is that good? So if I gave a problem like this, I would be asking for vertical asymptotes, holes, and horizontal asymptotes. Do you think you could handle that kind of problem?
So you're not going to X-ray domains?
No, because the domain and the vertical asymptote and holes are related, aren't they? See, the domain is limited by what? You couldn't have -3, you couldn't have 2. Because that makes the denominator 0. But -3 and 2 is what makes what? Vertical asymptotes and holes. Okay? I'm trying to go slow enough so you understand what. That's why I don't ask for the domain, because domains, verticals, and holes are all related. You understand? Okay. Okay. That was a good problem. It exemplified a lot of stuff. Any other questions?
I feel like we just do one on page, shoot. Hold on, I just had it, what is that, on 353? Like, probably like 11.
Before I go on, everyone's clear on this, because this is a good example problem. Now I'm going to do page 353 and number 11. Now notice that these are inequalities, right?
Yes.
The last one was an equality. So it's gonna graph, and it's gonna have holes and slants and verticals and all of that. So now this is going to be defined over certain ranges. That's what these problems are going to be. So it's x squared minus x minus 12, and then it's over x squared plus x minus 6 greater than 0. Now we're going to use what method to solve it? Critical values, right?
Yeah.
Critical values. Going to be the critical value method. So we're going to factor the numerators and denominators, set them equal to 0, and then have critical values, and then do that plus minus thing. Does that make? Does everyone see? Now, the critical values are always either in a solution or out of a solution. They're in a solution. First of all, let me back up. they're out of a solution. They will not be accepted for two reasons. They will not be in the solution. First one is, you look at this inequality. They're not going to be included if that inequality is what? Strictly greater or strictly less, no equal to, right? And what would be another reason that the critical values could not be in a solution? If they make the denominator what? 0. So if the critical values involve factors of the denominator, then they cannot be in the solution. Does that make sense? Because if you put them in, then it's going to make the denominator 0. Maria, did you understand what I said? Cassandra? You? So that's a couple things that you want to kind of remember. Now, in this kind of a problem, none of the critical values are in, so you're safe, right? You don't have to recognize which ones are critical values for the denominator. But when do you have to be very careful? When you have a little equal sign over there, right? Then you will think, well, my critical values are got to be in my solution, and you're apt to put something in when it's actually a critical value for a factor in the denominator, right? You understand what I'm saying? So that's when you can make a mistake. All right. So now what I'm going to do is I'm going to factor the numerator. And I'm going to factor the denominator. Okay, the numerator, how is it going to factor? Okay, x minus 4, x plus 3, is that what I heard? So x minus 4, x plus 3. The denominator is going to factor how? Okay, x plus 3 and x minus 2. Now, let's do the critical values for each one of those points. For x minus 4, its critical value is going to be what? X equals 4. The critical value for x plus 3 is going to be x equal minus 3, right? Critical value for x plus 3. Now notice the denominator has the same critical value as the numerator. Now if that were an equal sign, then that would be a whole, right? But this is an inequality. So we evaluate it differently. Then the critical value of x minus 2 has got to be x equal 2. All right. Now, when you do that plus minus stuff, you're going to have to do plus minus for x minus 4, x plus 3, and an x plus 3 again, and an x minus 2. Don't just do it for x plus 3 once, because you see the numerator and denominator have an x plus 3 in them, and they can be plus or minus, right? If you just do x plus 3 as a factor once, you can lead to an error. Because see, if you just do it once, and the x plus 3 is a negative, then it's apt to make that group negative. But if you do it twice, you have two negatives, and that group is positive, right? Correct? Now I'm going to set up my critical values. So I got to go from -4 to +3, right? 0. And I want to do, so I got a -4, I got to have a vertical one. Grant, you'll give me that as a -4, won't you? And -2, and then a +3. Now, this, I think I did something wrong here. I have a critical value at a +4, don't I? At a +4. And then +2. I did it backwards. And then a -3, right? You see, I did do it backwards, didn't I, when I first did it? Now this x -4, its critical value is clear over here, isn't it? And to the left of +4, it's negative. And to the right, it's positive. Now, at this critical value, is that critical value in or out? Okay, Savannah says out. Anyone agree with her? It's related to this. If it were in, what would that have to be? Greater than or equal to, right? So this one is out. Actually, all of them are what? Out. This 2 is out for two reasons. One is because the inequality is strictly greater than, and the other one is that it's a factor in the denominator, right? And the factor in the denominator's critical value has got to be out. Right? Okay, the other one that's a factor in the denominator is what? That x equal -3. So it's out for two reasons too, also. Okay. So we evaluated the factor x -4. Now then, we want to evaluate this factor right here, which is x +3, whose critical value is -3. And to the left of -3, this value is going to be negative, right? And to the right, it's going to be positive. Now then, if that's the x +3 from this numerator, this is the x +3 from the denominator, right? And to the left, that one is negative, right? And to the right, it's positive. Then that x -2, its critical value is +2. To the left, it's negative. And to the right, it's positive. Now, before we go on, I want to point out something to you. Why it's important that you use both of these factors. If you only used one, just one of them, notice in the region to the left of -3, it would become negative, wouldn't it? But if you use both of them, it becomes positive. Does that make sense? Do you understand what I'm talking about? So it's important that you use both factors. Otherwise, your signs will be backwards, right? Now, you know, it wouldn't make any difference wherever the x plus 3 is positive, but wherever the x plus 3 is negative, it would change your sign around. Now down below here, we are actually getting this whole thing, x squared minus x minus 12 over x squared plus x minus 6, because that's just all of those factors put together, correct? Right? So to the left of the first critical value, which is -3, you notice I have what, 4 negatives, so I got a positive. So I'm positive back here. Now, between the -3 and the +2, do you see what I have? I have a negative, plus, plus, minus. So what do I have? I have a positive still. Now from 2 to 4, I have 1 negative and 3 positive, so I got negative. And then to the right, I got what, all positives? Now, what's the solution? It says greater than, so what does it have to be? It's got to be positive, don't it? So it's everything from here back to there, and then from everything from there back, and then everything out here. Now if I wrote it in the notation, the interval, I'd say minus infinity to -3. Hang it. And then put in union with -3 to +2 in union with 4 to infinity. Correct? That's where it's going to be positive.
Do you want that?
I don't care. You can do it whichever way you want. You can do the graph like I did. But I think that the book probably does it the last way, don't it? So I do it that way so that you can see that. Yeah, it's okay. If you leave it like this, I'm okay with it.
Oh, and then writing.
Or you can go this way. The reason I'm doing this way is when you look in the book, which way is it going to give it to you? It's going to give it this way, right? So you won't know whether I did it right or wrong unless you see that. Okay, good questions, because they cover a lot of things that we're going to.
Professor, can you do question?
Anything else?
Professor, excuse me.
Oh, Tiffany, was it you?
Yes. Can you do question 5, page 267?
267?
sorry, 265, sorry.
255?
265.
Oh. And you said 7?
Number 5.
5. This is just long division, right?
Yeah.
Page 265. And you said number 5?
Yeah. Keep getting my correction.
9x cubed plus 5 divided by 2x minus 3. So what we have to do is we have to go 2x minus 3 and put 9x cubed. Then I'm going to leave some room, plus 5. Now what I ask is this. What do I have to multiply this by to get that number right there? Nine halves x squared, is that right? I have to put 9 halves x squared. Because when I do x times x squared, I get x cubed, right? And if I take 9 halves times 2, the 2's cancel out and I have 9, right? And it's minus 3 times 9 is 27 halves x squared. Okay, does that make sense? Then I have to change the sign, minus, plus, and then I'll have a 27 halves x squared. And I have to bring down my 5. Now I say, what do I have to multiply this by to get this? And I have to multiply it by 27x, don't I? 27x. So then it's 27 over 2x squared minus 3 times 27. 81x, is that right? Then I change my signs. This is a plus 81x plus 1. Now what do I multiply 2x by to get 81x? That's got to be what? 81 over 2? And that's going to get me 81x minus 3 into there is 20, no, 3 times that. This is 3, 24 over 2. I have to change my sign, negative, positive. What? Then I have to make this a 2 over 2. That's 10 over 2 plus 243 over 2 gives me 253 over 2. And that's going to be a remainder. Or just a remainder. 253 over 2. That's a pretty hard problem.
So you don't have to stop, just use that.
No, you won't get that problem.